Hello, and welcome back to Teacher Gimble's Classroom. Today we're going to be going over Illustrative Math, Algebra 1, Unit 1, Lesson 5. If you like my videos, please like this one and subscribe below. If you have any questions or want to see different content, leave it in the comments and I'll see. Alright, let's get started. Problem 1. The dataset represents the number of errors on a typing test. What is the median? Interpret this value in the situation. So we've been working with the median for the past few lessons now. So at this point, we should know that the median means what's the middle number. So let's go ahead and identify it. I do it by crossing out the values on either end so that I can figure out what the middle value is. I crossed out one too many there, and I notice we have two middle numbers. In this case, when we have two middle numbers, we always add them together and divide by 2. And we get 9. What does this mean in this situation? Well, firstly, this 9 represents errors. So I'm going to put the context there. It means that the median says that 50% of the data falls above the median and 50% of the data falls below the median. So our median's in there is a 9 because it's in between those two 9s. So it means 50% of the students made less than 9 typing errors and 50% of the students made more than 9 typing errors. If you need to take a second to write down the answer to this question, feel free to pause the video and keep going when you're ready. Question number 2. What is IQR? IQR is a special way of writing interquartile range. Now, in our other videos, we talked about finding Q1 and Q3. So we've already found the median. After we find the median, we can go ahead and find Q1 and Q3. And these are just the medians of the top part of the data and the bottom part of the data. So my top part of the data is right there. If I want to find the median, I'm going to do exactly the same thing I did before and go ahead and find the middle value. Because that's the top part of the data, that's Q3. Now for the lower half of the data, I'm going to do exactly the same thing. Go ahead and find the median with the lower half of the data, and that gives me Q1. Now IQR has a simple formula, which is Q3 minus Q1. We've already calculated Q3 as 10, and we've already calculated Q1 as 8. So it will be 8 minus 2, 10 minus 8, which is equal to 2. And that's our answer. I always like to write my things out in boxes and tables so I can clearly see exactly what I'm calculating. Let's move on to question number 2. The data set represents the heights in centimeters of 10 model bridges made for an engineering competition. What is the mean? What is the MAD? So let's go ahead and find the mean. The mean, also known as the average, you can find by adding up all the numbers and dividing by however many there are. So in this case, we're going to add 13 plus 14 plus 14 plus 16 plus another 16 plus another 16 plus another 16 plus 18 plus 18 plus 19. And we're going to divide by the number there are, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 data points. After we do this, we're going to plug it into a handy-dandy calculator and calculate this value. So we've added them all up, and our top value is 190 divided by 10. I don't know. So 190 divided by 10 values gets us 19 as the mean. We're going to write 19 errors equals mean. Now over here, we're asking for the MAD. The MAD means mean, average, distance. So we're going to have to calculate the average distance each of these data points is away from the mean. So our mean is 19, which does not make sense in this context. So we got to pause and do some recalculation. So I did some calculator errors, which is something to happen. But when I have the mean of 19, 19 is my biggest value, and I know my mean's going to go somewhere out in the middle. So I went ahead and I recalculated my mean because I realized I put it in the calculator wrong. So I went and re-added up all of those values, and I got 160 divided by 10, which gives me 16 errors as my mean. Now, I'm leaving these mistakes that I make in my video because these are mistakes that everybody makes. And it's important to not just know the correct answer, but also know that everybody makes these mistakes and how to pause and check and go back and check yourself. So when I saw that 19 was a value that was way too high to be my mean, that told me, let me take a second, recalculate, and see if I did my error. And for me, I had just typed something in the calculator incorrectly. So let's go back to finding the MAD, or the mean average distance. So to find the mean average distance, we're going to start by finding out what is the distance of each point from our mean. So 13 is 3 values away from our mean, because 13 plus 3 gets you 16. 14 is 2 values. This 14 is 2 values. 16 is the same as our mean. So all of these are no distance from our mean. 18 is 2 away from the mean. This is 2 away from our mean of 16. And this is 3 away from our mean. So we first calculate the distance each point is from our mean. Now it is important to remember, even though some are lower and some are higher, the distance away from the mean is always a positive number. We're now going to calculate the mean average distance. So we're going to add them all up, just like we did before. So 3 plus 2 plus 2, that gives us 7, plus 4 zeros, plus another 2, plus another 2, plus a 3, all divided by the number of values there are. And this we can do in our head. So 5, 7, 9, 11, 14. 14 divided by 10, which gives us 7 over 5. This right here is our mean average distance. So to go over that, to calculate your mean average distance, I found the distance of each point away from our mean. So 13 minus 16, so it's 3 away from the mean. 14 minus 16, it's 2 away from the mean. I calculated that for each value, I added it up, I took the average, and I got our mean average distance. Feel free to pause the video or post comments or questions below if you have a question. Problem number 3. Describe the shape of the distribution shown in the dot plot. The dot plot displays the golf scores from the golf tournament. So I always like to trace my distributions when I'm doing this. As I'm tracing this, I notice that I come out with a tail. This guy's my tail. Whenever I have a tail, that means my graph is skewed. My tail is on the right side of the graph, so the shape is skewed right. That's it. Let's go ahead to the next question. The dot plot shows the weight in grams of several different rocks. Select all the terms that describe the shape of this distribution. So let's go ahead and look at this. I'm going to go ahead and I'm going to trace this. Again, because tracing it helps me see my shape. It does not look like a bell shape or a mound shape. Because a bell shape or a mound would look like this. Bimodal, bi is 2, like you've got 2 wheels on a bicycle. So bimodal means it has 2 separate humps. Over here, I'm seeing 2 humps, so I like that. That is a description here. Skewed. I don't see a tail here. I don't see a tail here. So I'm going to say we are not skewed. Symmetric. If you remember from one of the early videos, symmetric means it's the same on one side as it is on the other. Over here, this mound is very similar to that mound, so I'm going to say this is symmetric. Uniform means each data value is the same, or has the same number of dots. In this case, we see that there are a different number of points for each data value, so we're not uniform. So our answer to this question would be it's a bimodal symmetric distribution. All right, question number 5. The dot plot represents the distribution of wages earned during a 1-week period by 12 college students. So we have 12 students. The lowest one made 112, the highest made 124. What is the mean? Interpret this value based on the situation. So to get the mean, we have to add up all of our values as we've just been doing. This is 112, this is 114, which means this value in the middle has to be 113. We have 3 students who made 116 because I see 3 dots here. So I add 3 116s. We have 2 who made 118. We have 2 who made 119. And we had 3 who made 124. So we pull out our handy dandy calculators. We take a second and we're going to calculate the sum of all of those values. I calculated the sum of those values to be 1419. Now I already know that there are 12 students, so I say 1419 divided by 12 gets me a mean of 118.25. Now here, I quickly check, 118.25 is right about over here, which makes sense in terms of having our mean. So this represents dollars because a number here represents weekly wages in dollars. So it means the average amount a student made in a 1 week period was $118.25. What is the median? Interpret this value based on the situation. Okay, back to the median. We cross out a point here, in there, here, in there, here, and here. Remembering that each dot represents one data value, so we're left with this in the middle, which are these two dots, which is 118. That's 118 divided by 2. And if you've seen this enough times, you'll realize that when it's the same two numbers, the median is going to be that number as well, which gives us 118. So again, we're at $118. Because it's money, I'm going to put a decimal point and 2 zeros afterwards. And interpreting this value means that half of the students made below $118 and half of the students made above $118, which in this case, because there's 12 students, the median means that 6 students made less than $118 in this data set and 6 students made more than $118 in this data set. Finally, would a box plot of the same data have allowed you to find both the mean and the median? Now we know in our box plot, if I'm tracing a box plot over here, and this is just a sketch of a random box plot, that this right here has the median. So yes, we would be able to find the median in a box plot. However, we also know that we're missing the individual data points of the box plot. And without the individual data points, we can't do this calculation over here. So while we can find the median, we cannot find the mean from a box plot. Problem number 6. The box plot displays the temperature of saunas in degrees Fahrenheit. What is the median? Oh, I could go to a sauna right now. Well, we just talked about it. The median is always represented by that middle line. We've got a middle line right here. It's at 118. The median of this data is 118 degrees Fahrenheit, which is actually the same as the median of this data up here. So half of the saunas are less than 118 degrees and half of the saunas are more than 118 degrees. If you have any questions, let me know in the comments below. Thanks for listening to this, and if you like this video and want more, please like and subscribe so I can make you some more videos. All right, have a great day.